Good morning, students. We are almost completed 2 units under surface chemistry, namely adsorption as well as the catalysis. Since many of the units have been deleted, therefore little early we are completing the units. Nothing deleted in the adsorption, we have discussed all the information. Whereas in the catalysis, we studied what is catalyst, what is catalysis, what are catalytic promoters, catalytic poisons, with the examples we studied. Then homogeneous and heterogeneous catalysis is not there for the syllabus, we are not studied. Then regarding enzyme catalysis is not there, therefore general characters of enzymes, enzyme catalysis, its mechanism also not studied. Mainly shape selective catalyst, the substance which depends on pore structure and size of the catalyst. Due to honeycomb like structure, zeolites are used as a shape selective catalyst. Zeolites are nothing but hydrated aluminosilicates, among which one of the best example ZSM5 is an example for zeolite, which is used to convert alcohol directly into gasoline. Okay, main you have to indicate the pore structure and size of the particle, it depends. Due to honeycomb like structure, the shape selective catalysts are used for in the petrochemical industries. Example, ZSM5 is used as a zeolite used to convert alcohol into gasoline. By chance, if they are asking what are zeolites, zeolites are the hydrated aluminosilicate polymers. Briefly, you should indicate regarding applications. You should not feel difficult to give the applications of a catalyst, because any suitable example if you are giving by indicating a particular process, by indicating particular catalyst, that becomes the proper application. Or else what you studied in the earlier topic of a P block elements, you can recall all those. During the manufacture of ammonia by Haber process, iron oxide is used as a catalyst, molybdenum or potassium oxide or aluminum oxide is used as a promoter, you can say. Writing reaction is not necessary, but I have written because easy to remember the details. Similarly, during the manufacture of a sulfuric acid by contact process, main reaction is oxidation of sulfur dioxide into sulfur trioxide. During the process of oxidation, platinum or vanadium pentoxide is used as catalyst. Similarly, during the manufacture of during the manufacture of nitric acid by Ostertag process, first reaction is oxidation of ammonia into nitric oxide. There we are using platinum catalyst, or platinum rhodium gas is used as catalyst. Example, the reaction I have written. So reaction ಬೇಡ ಅಂದ್ರೂ ಸಹಿತ reaction with the conditions ನೆನಪಿಟ್ಕೊಂಡ್ಬಿಟ್ರೆ it becomes easy, because these reactions you needed for P block elements. That is the completion of a second unit under surface chemistry, namely adsorption and catalysis. The third unit, little lengthy unit of the surface chemistry, is regarding the colloids. Okay, we'll go for the colloids little details. Colloids is the third part of the unit. differences types of the substances. We can have the definition afterwards. So in one test tube you have a water into which salt NaCl is dissolved. You will get sodium chloride solution that is to be considered as true solution. In another case, we are going to take the test tube having water into which chalk powder is added. That chalk powder is due to gravity settles to the bottom. This becomes the suspension, or else you may say that during the process if you are getting the precipitate, that is considered as a suspension. In between these two, you can go for one more simple experiment in which you are going to take the test tube having water into which you can take protein powder or a starch powder is added and shaken well, this becomes the colloid. What could be the main difference? Between these three types of a solution if you are asking? One of the point I will consider, you can go for remaining points afterwards. True solution is a solution in which the dispersed particles, sodium chloride particles, cannot be seen through the naked eyes and also cannot be seen through the microscope. ಟ್ರೂ ಸೊಲ್ಯೂಷನ್ ಅಂತ ಯಾವ್ದು ಕರಿಬೇಕಂದ್ರೆ ಯಾವುದೇ ಒಂದು ಸೊಲ್ಯೂಷನ್ ನಲ್ಲಿ ಕರಗಿಸಿರ್ತಕ್ಕಂಥ ಡಿಸ್ಪರ್ಸ್ಡ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಗಳನ್ನ ಬರಿಗಣ್ಣಿನಲ್ಲೂ ನೋಡ್ಲಿಕ್ಕೆ ಆಗಲ್ಲ, ನೀವು ಮೈಕ್ರೋಸ್ಕೋಪ್ ಅನ್ನು ಬಳಸಿದರೂ ನೋಡ್ಲಿಕ್ಕೆ ಆಗಲ್ಲ. ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಎಸ್ ಎ ಟ್ರೂ ಸೊಲ್ಯೂಷನ್. ಕಮಿಂಗ್ ಟು ಸಸ್ಪೆನ್ಷನ್ ದಲ್ಲಿ ನೀವು ಚಾಕ್ ಪೌಡರ್ ಅನ್ನ ಹಾಕಿದ್ದೀರಿ, ಡ್ಯೂ ಟು ಗ್ರಾವಿಟಿ ಇಟ್ ಸೆಟಲ್ಸ್ ಟು ದ ಬಾಟಮ್. ಇಲ್ಲೇನು ಹೇಳ್ಬೋದು ನೀವು ಸಿಂಪಲ್ ಆಗಿ, ದ ಡಿಸ್ಪರ್ಸ್ಡ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಕ್ಯಾನ್ ಬಿ ಸೀನ್ ಥ್ರೂ ದ ನೆಕೆಡ್ ಐಸ್. ಮೈಕ್ರೋಸ್ಕೋಪದ ಅವಶ್ಯಕತೆನೇ ಇಲ್ಲ, ನೇರವಾಗಿ ಬರಿಗಣ್ಣಿನಲ್ಲಿ ನೋಡಬಹುದು. ಅವೆರಡರ ಮಧ್ಯೆ ನೀವು ಪ್ರಾಪರ್ಟಿಯನ್ನು ಕೊಟ್ಟರೆ ದಟ್ ಬಿಕಮ್ಸ್ ಕೊಲಾಯ್ಡ್. ಕೊಲಾಯ್ಡ್ ಇಸ್ ಎ type of substance in which the dispersed particles cannot be seen through the naked eyes but can be seen through the microscope. Is the one of the general statement I have given, but actual after knowing the brief information, it is in between true solution and suspension. Now we go for the exact definition for colloids. Colloids is the third unit under the surface chemistry. Colloid is a heterogeneous system. Colloid is a heterogeneous. It is a heterogeneous system in which one substance is dispersed in another. One type of a substance is dispersed in other type of a substance is called as a colloid, or else you can give the exact definition based on the particle size, in which the size of dispersed particle, lies between 1 to 1000 nanometers. This is the best point we are using to distinguish, to give the definition for the colloids. Colloid ಗಳಲ್ಲಿ ಇರತಕ್ಕಂತ dispersed phase of the particle size 1 ರಿಂದ 1000 ನ್ಯಾನೋಮೀಟರ್ ಮಧ್ಯೆ ಇರುತ್ತೆ ಅಂದ್ರೆ, ಅಥವಾ it lies between 10 to the power of -9 to 10 to the power of -6 meters. is the better definition. We can have the different types of method to classify the colloids. One method is based on the state of a dispersed phase and dispersion medium. We have different types. Main heading classification. Sub number 1. It is based on the physical state. Based on the physical state of dispersed phase and dispersion medium. We have different types of colloids. It is better to study in the form of a tabulation. We will make 4 columns. First one is dispersed phase. Second is dispersion medium. Third one is type of colloid. What is the type of colloid? We called it as, you can have the one example for each. If the dispersed phase is a solid, dispersion medium is a solid, then it is called as a solid sol. For example, colored glass ಅನ್ನು ತೆಗೆದುಕೊಂಡ್ರೆ ಅಲ್ಲಿ ಏನು ಕಲರ್ಡ್ ಕಾಂಪೋನೆಂಟ್ ಹಾಕಿದ್ರಲ್ಲ ಡಿಸ್ಪರ್ಸ್ಡ್ ಪಾರ್ಟಿಕಲ್ ಅದು ಸಾಲಿಡ್, ಮೀಡಿಯಂ ಮೋಲ್ಟನ್ ಸ್ಟೇಟ್ ಅಲ್ಲಿ ಇರುತ್ತಲ್ಲ ಅದು ಸಾಲಿಡ್ ಆಗಿದೆ, that is called solid sol. Important is, if the dispersed particle is phase is a solid, dispersion medium is a liquid, it is called as a sol. Refer once again, may be important. If the dispersed particle is a solid, dispersion medium is a liquid, then it is called as a sol. For example, solid, liquid, sol. For example, protein sol, starch sol, gold sol are the examples. If the dispersed phase is a solid, dispersion medium is a gas, it is called as a solid aerosol. It is called it as, for example, smoke, dust, etc. are the examples. Now solid is common, we are going to change solid, liquid, gas. Okay, this is sub number 1. Next comes the liquid. If the dispersed phase is a liquid, dispersion medium is a solid, then it is called as a gel. For example, jellies, any type of a petroleum jelly we are using, Vaseline, jellies and cheese are the example for that. If you have both are liquid, important, both are liquid. If a dispersed phase is a liquid, dispersion medium is a liquid, it is called as emulsion. For example, emulsified milk. Emulsified milk is the example for that. If the dispersed phase is a liquid, dispersion medium is a gas, it is called liquid aerosol. For example, smog, fog, cloud are the example for that. Fog. Now we go for gas, solid, gas dispersed phase, solid is dispersion medium, it is again called solid sol, again called solid sol, solid aerosol. For example, foam, rubber are the example for that. And lastly, gas liquid is called foam. For example, soap, lather, etc. Among these, very important is, If the dispersal phase is a solid, dispersion medium is a liquid, it is called as a salt. For example, gold salt, silver salt, platinum salt, protein salt, starch salt. If the dispersal phase is a liquid, dispersion medium is also liquid, then it is called as a emulsion. For example, emulsified milk. Okay, if the dispersal phase is a liquid, dispersion medium is a solid, then it is called as a gel. You are using the term Colgate gel, any toothpaste, jellies, cheese are the example for those. ಯಾವುದು ಡಿಸ್ಪರ್ಸಲ್ ಫೇಸ್ ಇದೆ, ಯಾವುದು ಡಿಸ್ಪರ್ಷನ್ ಮೀಡಿಯಂ ಇದೆ ಅನ್ನೋದ್ರ ಮೇಲೆ ನಾವು ಬೇರೆ ಬೇರೆ ಟೈಪ್ ಕೊಲೈಡಲ್ ಸಿಸ್ಟಮನ್ನು ಗಮನಿಸಬಹುದು. ಯು ಕ್ಯಾನ್ ಎಕ್ಸ್ಪೆಕ್ಟ್ ದ ಎಕ್ಸಾಂಪಲ್ ಫಾರ್ ಇಂಡಿಕೇಟಿಂಗ್ ದ ನೇಮ್. ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಅದು ಹೀಗೆ ಕೇಳ್ಬೋದು, ಮೆನ್ಷನ್ ದ ಡಿಸ್ಪರ್ಸ್ಡ್ ಫೇಸ್ ಆ್ಯಂಡ್ ಡಿಸ್ಪರ್ಷನ್ ಮೀಡಿಯಂ ಇನ್ ಜೆಲ್ ಅಂತ ಕೇಳಿದರೆ, ಡಿಸ್ಪರ್ಸ್ಡ್ ಫೇಸ್ ಈಸ್ ಲಿಕ್ವಿಡ್, dispersion medium is solid. Okay, if the dispersal phase and the dispersion medium both are liquid, what type of does collide is called as? It's called as emulsion. Okay, then we can have a solid, liquid, solid anta helidiralla. Adrallene which is the liquid you are making use, there you can have different subtypes. Among these solid, if you want to say, among the solid, if you have hydrosol, alcohol, benzosol are the subtypes in which the dispersion medium, little confusable is first one. Some students may say that the dispersion medium in the hydrosol is hydrogen. It is wrong. In hydrosol it is water. In alcohol it is alcohol. In benzosol it is benzene. One marking a confused marking ಕೇಳಬಹುದು. Name the dispersion medium in hydrosol. If they are asking, it is water. This is the first type of a colloidal classification. Second is based on the interaction between the dispersal phase and dispersion medium. There are two types of colloids. Dispersal phase ಮತ್ತು dispersion medium ಯಾವ ರೀತಿ ಇಂಟರಾಕ್ಷನ್ ಹೊಂದಿದೆ ಅನ್ನೋದರ ಮೇಲೆ ಎರಡು ರೀತಿ colloids ಅನ್ನು ಕ್ಲಾಸಿಫೈ ಮಾಡಬಹುದು. One is lyophilic colloid, another is lyophobic colloids. We will have the definition and also example. Apart from that, we can also have some important points we are using to differentiate between those. Second is based on the interaction between dispersal phase and dispersion medium. There are two types. Number one is lyophobic colloids. If I give the meaning for the heading in the Greek language, you can give the definition easily. In a lyophobic colloid, the meaning of lyo is solvent. In that word, phobic means hating. What would be the definition? Brief, I can say. Briefly, I can say lyophobic colloids are the solvent hating colloids. Under normal temperature, if you are not going to maintain drastic condition, under normal condition, if any dispersal phase have no affinity towards the dispersion medium, they are called as a lyophobic colloids. They are called as a solvent hating colloids. The colloid, the type of a colloid in which in which the dispersed phase have no affinity with the dispersion medium, under normal conditions. ಒಟ್ಟಾರೆ ಡಿಸ್ಪರ್ಸ್ಡ್ ಫೇಸು ಡಿಸ್ಪರ್ಷನ್ ಮೀಡಿಯಮ್ಮು ಎರಡೂ ಸೇರ್ಕೊಳ್ಳೋದೇ ಇಲ್ಲ ಅಂದರೆ ಕೊನೆಗೆ ಪ್ರಿಪೇರ್ ಆಗಲ್ಲ. ನಾವು ಹೇಳಬೇಕಾಗಿರೋ ಉದ್ದೇಶ ಇಷ್ಟೇ, ಅಂಡರ್ ನಾರ್ಮಲ್ ಕಂಡೀಷನ್ಸ್, ಅಂಡರ್ ಗಿವನ್ ಕಂಡೀಷನ್ಸ್, if the dispersed particle have no affinity with the dispersion medium, they are called as a lyophobic colloids. If water is used as a solvent in that colloid, you may call it as a hydrophobic colloids. Generally lyophobic. Okay, particularly if you are using the water as a solvent, then you may call them as a hydrophobic colloids. For example, gold salt. ನೀವೇ ವಿಚಾರ ಮಾಡಿ, ಗೋಲ್ಡ್ ಪೀಸ್ ಅನ್ನು ನೀರಿಗೆ ಹಾಕಿದ್ರೆ ಏನಾದರೂ ಸೊಲ್ಯೂಷನ್ ಕೊಲೈಡ್ ಪ್ರಿಪೇರ್ ಆಗುತ್ತಾ? ಇಲ್ಲ. ಗೋಲ್ಡ್ ಸಾಲ್ಟ್, ಪ್ಲಾಟಿನಮ್ ಸಾಲ್ಟ್, ಸಿಲ್ವರ್ ಸಾಲ್ಟ್, gold salt, platinum salt, silver salt are the examples for the lyophobic colloids. Gold piece ಅನ್ನು ನೀರಿಗೆ ಹಾಕಿದರೆ ಯಾವುದೇ ಟೈಪ್ ಕೊಲೈಡ್ ಪ್ರಿಪೇರ್ ಆಗೋದಿಲ್ಲ. ಆದರೆ ಅದೇ ಗೋಲ್ಡ್ ಅನ್ನು ಎಲೆಕ್ಟ್ರೋಡ್ ರೀತಿಯಲ್ಲಿ ಅತಿ ಹೈ ಟೆಂಪರೇಚರ್ ಮಾಡಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಆರ್ಕ್ ಮತ್ತೆ ಸ್ಟ್ರಕ್ ಮಾಡಿದರೆ ವೇಪರ್ ಆಗಕ್ಕೆ ಟ್ರೈ ಮಾಡುತ್ತೆ. ಕೋಲ್ಡ್ ಕಂಡೀಷನ್ದಲ್ಲಿ ವಾಟರನ್ನು ಇಟ್ಟಾಗ ವೇಪರ್ಸ್ ಕಂಡೆನ್ಸ್ ಆಗಿ ವಾಟರ್ದಲ್ಲಿ ಸೇರಿಕೊಂಡು ಕೊಲೈಡ್ ಪ್ರಿಪೇರ್ ಆಗುತ್ತೆ. ದಟ್ ವಿ ಆರ್ ಕಾಲಿಂಗ್ ಎಸ್ ಎ ಗೋಲ್ಡ್ ಸಾಲ್ಟ್. ವಿಲ್ ಹ್ಯಾವ್ ದ ಡಿಸ್ಕಷನ್ ಆಫ್ ಎ ಪ್ರಿಪರೇಷನ್ ಆಫ್ಟರ್ವರ್ಡ್ಸ್. ಇದನ್ನು ಎಕ್ಸಾಕ್ಟ್ ರಿವರ್ಸ್ ಮಾಡ್ತಾ ಹೋಗಿ ಇಟ್ ಬಿಕಮ್ಸ್ ಅಪೋಸಿಟ್ ಟು ದಟ್. ಲಯೋಫಿಲಿಕ್ ಕೊಲೈಡ್ಸ್. Lyophilic colloids is another type. If I give the meaning for that, lyo means as it is solvent, philic means loving. ನೀವೇ ಕೊಡಬಹುದು ನೋಡಿ definition ಅನ್ನು. Rough definition anybody can give. Lyophilic colloids are the solvent loving colloids. Okay, ಆ ರೀತಿ ಗೊತ್ತಿರಲಿ, ಬರೆಯೋದು ಬೇಡ. ಇದರ ಅಪೋಸಿಟ್ ಮಾತಾಡೋದು. The colloid in which dispersed phase have affinity with the dispersion medium. No, the type of a colloid in which dispersed phase have affinity towards the dispersion medium are called as lyophilic colloids. If water is used as a solvent, then they are called as a hydrophilic colloids. They are called as a hydrophilic colloids. Okay. For example, protein salt, starch salt, etc. What it means? If you take a protein powder, that is protein powder is added to the beaker containing little warmed water and shake it well without a drastic condition, you will get the colloid. Protein powder ಅನ್ನು ಅಥವಾ ಸ್ಟಾರ್ಚ್ ಪೌಡರ್ ಅನ್ನು ತೆಗೆದುಕೊಂಡು ಬೀಕರ್ ಅಲ್ಲಿ ಹಾಕಿ ಆ ಬೀಕರ್ ಅಲ್ಲಿ ಸ್ವಲ್ಪ ವಾರ್ಮ್ ಆಗಿರತಕ್ಕಂಥ ವಾಟರ್ ಅನ್ನು ತೆಗೆದುಕೊಂಡು ಪ್ರೋಟೀನ್ ಪೌಡರ್ ಹಾಕಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಸ್ಟರ್ ಮಾಡಿ ನಿಮಗೆ ಸಾಲ್ಟ್ ಸಿಗುತ್ತೆ, ಕೊಲೈಡ್ ಸಿಗುತ್ತೆ. That becomes the lyophilic colloids. These are the definition along with the example. Apart from the definition and example, you can also consider some other differences between those two. They are the soluble, they are reversible. They are reversible. These are irreversible. They are reversible and irreversible. You can practice writing these differences by making two columns. One column ಮೇಲೆ ಲಯೋಫೋಬಿಕ್ ಕೊಲೈಡ್ಸ್ ಅಂದ್ರಿ, ಇನ್ನೊಂದು ಕಾಲಮದ ಹೆಡ್ಡಿಂಗ್ ಲಯೋಫಿಲಿಕ್ ಕೊಲೈಡ್ಸ್ ಅಂತ ಹೇಳಿ. ಒಂದನೇದು ಡೆಫಿನಿಷನ್ ಬರೀರಿ, ಎರಡನೇದು ರಿವರ್ಸಿಬಲ್ ಇರ್ರಿವರ್ಸಿಬಲ್ ಯು ಕ್ಯಾನ್ ರೈಟ್. ಥರ್ಡ್ ಒನ್ ಇಸ್ they are stable, they are stable, they are unstable. There's one is stable, another is unstable. And first one cannot be coagulated easily, cannot be coagulated, cannot be coagulated easily by adding suitable electrolyte. Here it can be coagulated easily by adding suitable electrolyte. ಬರ್ತಿರ್ತಕ್ಕಂಥ ಪಾಯಿಂಟ್ಸ್ ಅನ್ನೇ ನೀವು ಸೆಲೆಕ್ಟ್ ಮಾಡಿಕೊಂಡು ಎರಡು ಸಪರೇಟ್ ಕಾಲಮ್ ಮಾಡಿ ಲಯೋಫೋಬಿಕ್ ಮತ್ತು ಲಯೋಫಿಲಿಕ್ ಕೊಲೈಡ್ಸ್ ಅಂತ ಹೆಡ್ಡಿಂಗ್ ಕೊಟ್ಟು ಯು ಕ್ಯಾನ್ ರೈಟ್ ದ ಡಿಫರೆನ್ಸಸ್ ಆಲ್ಸೋ. ಇನ್ ಅ ರೇರ್ ಕೇಸಸ್ ಯು ಕ್ಯಾನ್ ಎಕ್ಸ್ಪೆಕ್ಟ್ ದ ಕ್ವಶನ್ ಫಾರ್ 3 marks. ಸಪ್ರೇಟ್ ಆಗಿ ಡೆಫಿನಿಷನ್ ಎಕ್ಸಾಂಪಲ್ಲು ಕೇಳ್ಬೋದು, ಅಥವಾ ರೈಟ್ ಎನಿ 2 ಡಿಫರೆನ್ಸಸ್ ಬಿಟ್ವೀನ್ ಲಯೋಫೋಬಿಕ್ ಆ್ಯಂಡ್ ಲಯೋಫಿಲಿಕ್ ಕೊಲೈಡ್ಸ್ ಅಂತ ಕೇಳಿದ್ರು ಬರಲಿಕ್ಕೆ ಸಾಧ್ಯತೆ ಇದೆ. ದಟ್ ಈಸ್ regarding second type of the classification of colloids. Third type of classification of colloids is based on the type of dispersed phase. ಯಾವುದು dispersed phase ಅನ್ನು ತೆಗೆದುಕೊಳ್ತಾ ಇದ್ದೀರಿ, ಅದು ಯಾವ ರೀತಿ ಫಾರ್ಮ್ ಆಗುತ್ತೆ ಅನ್ನೋದನ್ನು ಪರಿಗಣಿಸುವ ಮುಖಾಂತರ you can classify the colloids into multimolecular colloids, macromolecular colloids, and also associated colloids, nothing but micelle formation. The third type of classification is based on the type of dispersed phase. Type of dispersed phase. Based on the type of dispersed phase, they may be classified into multimolecular colloids, macromolecular colloids, and also associated colloids or micelles. Multimolecular colloids is the first subtype. Large number of atoms or a small molecules are going to aggregate to form the species having the size in the colloidal range are called as multimolecular colloids. ಮೊದಲಿಗೆ separate atoms ಅನ್ನ separate molecule ಅನ್ನ ತೆಗೆದುಕೊಂಡಾಗ they are not the colloids. When the large number of the small atoms or the molecules are going to combine, are going to aggregate to form the species or a solution in which the particle size range lies is similar to that of the colloid, they are called as a multimolecular colloids. I can repeat once again. Then macromolecular colloids. Macromolecular colloids. For the first type of colloid, you can use example gold salt, sulfur salt, gold salt, sulfur salt, protein salt, etc. Macromolecular colloids, they are the concerned to the polymers, natural polymers like proteins, starch, cellulose. You can take an example how they are originally. When you take that type of a substance in the substance in a suitable solvent, if you add, they will become macromolecular colloids of a size equal to that of the true solution. For example, as I said, polymers, natural polymers like protein, cellulose, starch, etc. You can take natural polymers and synthetic polymers, polythene, nylon, polystyrene, synthetic rubber, bunyl, bunyless rubber, etc. Whereas associated colloids are also called as micelles. Micelle formation means initially the particles at substance act as a strong electrolyte at low concentration, but at high concentration they exhibit the solution having the particle size constant to the electrolyte. Originally ಇರತಕ್ಕಂತ ಸಬ್ಸ್ಟೆನ್ಸ್ಗಳು they act as electrolyte at low concentration. If you are going to maintain the high concentration, they behaves as a at a high concentration they behaves as a colloid of same size range. They are called as a associated colloids or micelle formation. The formation of micelle takes place only above the particular temperature is called as a Croft temperature, and only above the particular concentration is called as critical micelle concentration. For the soap will have the critical micelle concentration lies between 10 to the power of -4 to 10 to the power of -3 moles per liter. It is mainly concerned to the formation of a soap in the form of a colloids. We can have the details once again. Based on the type of a dispersed phase, multimolecular colloids, macromolecular colloids, and also associated colloids. Multimolecular colloids ಅಂದ್ರೆ large number of atoms ಅಥವಾ molecules ಸೇರಿಕೊಂಡು will become a colloid. Macromolecular colloids ಅಂತ ಹೇಳಿದ್ರೆ macromolecular colloids means when a particular substance is going to dissolve in a particular solvent, then they behave as a colloid. Associated colloid andre the substance behaves as electrolyte at a low concentration, but at high concentration they will become nature of a colloid or the three types. Before to that, we must have one more information regarding true solution, suspension, colloid ಬಗ್ಗೆ discuss ಮಾಡಬೇಕು. Then we have different methods of preparation of the colloids. We have different methods of preparation of the colloids. Then purification we will study in the afterwards.